So today's lecture is about generics, and the alignment's way off, and I can't figure out how to calibrate. That's almost unusable. So instead, I will just type in here. Okay, so generics are like templates in C++. The idea is that it's supposed to be a big time saver. So when we write a class that's supposed to hold a collection of other types of objects, remember we discussed composition the other day, and frequently the composition is a one-to-many, and that is we have one object that's made up of a whole bunch of other of the same type of objects. Okay, so in that case, we'll be storing one of our instance variables is going to be something like an array list that contains a whole bunch of things. So I usually call those collection classes when they contain, a bunch of other items, which can be of all different classes, but we could have several items of all the same class. So why is that important for an array list? Why do we want to be able to specify the type that it holds? So let's just make up, how about tire? Yes? Yeah, you are. Thanks for saying something.
They'll definitely be 4 people. They'll definitely deal with it. We might just post it on
Display.
which is right next to it.
Yeah, I think the film's right across the street.
We might all pitch in and get a pizza. Like everyone pitch in like $5.
Okay.
Me and Andy will end up pitching up 10 because we're pretty much going on the same account. But that'd be $20. That's enough for like one large pizza. One extra large pizza. Jets is fantastic. Jets is my favorite place.
I think I've had it. Pretty good.
Like they used to have this thing, it was
Display settings?
deep, thick crust pizza, except for they wrapped it fantastic. So expensive.
Okay, sorry about that. Okay, so as I was saying, generics, like templates, are supposed to be a big time saver. And that's, if we wanted to write an array list that was capable of holding any type of object, there's a couple of ways that we can do that in Java. There's something called an object class, which we'll be doing a lot more with later. So if I just do the following code, if I got something like just usual object creation using the new keyword, this array list is built so that it will hold the object type. Now, that's something that Java has that C++ doesn't. It has a top-level class. Everything is an object, and that's object. Okay, the object class is the top-level class. So it doesn't matter what class we try to create, it's also considered by Java to be an object. Okay? Now that's jumping ahead a little bit. We're going to talk more, that comes from inheritance, and we talk more about exactly what's going on behind the scenes there. But suffice it for now to say that, let's see if this will make the most sense. So object provides a couple of methods. One of those being toString. So remember what I said about system.out.println when you provide it with an object. Let's call it just my object. It automatically calls the toString method. And of course, this will work for anything. Anything I throw inside system.out.println, if I give it any kind of object, it will automatically call the toString method. So everything has a toString method, and this is a consequence of the fact that everything is considered to be an object. Okay? So in fact, when I create an array list this way, it can hold absolute anything that's constructed to hold objects. Well, everything in Java is an object. The problem is, if I use the get method to return something, here's the method signature for get in the array list class, it's going to give me back type object. And that's going to cause problems for us until we learn more about inheritance. Okay? We have to do casting, which you probably did some of in C++. So that's where generics comes in. I would really not be forced. So one option is to do this. Write your array list class so it accepts type object, which really means it accepts everything. Okay? That saves you some time. You don't have to write an array list that will hold tires. You don't have to write an array list that will hold shoes. Okay? If I did that, if I wrote an array list, tire, A-L-T, I could write my own class called ArrayListTire. Then I can make the get method return whatever I want it to return because I'm making my own class. I'm not using the built-in array list. Okay? So I know it's going to store tires. I provide it tires when I add to the list. I get tires out when I call the get method. I remove tires when I call remove. Okay? It's all hard-coded in there to work, like an array list usually works, but specifically for tires. The problem becomes now I want an array list for pizzas. So I got to copy and paste that array list, all the work that I did for the first array list, and now come along and write an array list pizza class that works correctly for pizza. Okay, and very quickly we see this is going to be not sustainable. Every time we want to store a different item in the array list, we have to basically copy and paste and change the parameters. Okay? So that's not going to work for us. So we've got our choice without generics is write one where you can put anything in there. In fact, the problem with writing an array list that holds objects is I can mix together tires and pizzas. I can put a few tires in there. I can put a few pizzas in there. It'll think everything is fine. Okay? Well, generally, you don't want to do that. I also don't want to have to write an array list or some kind of collection class for each individual type of specific object that I wanted to hold. So neither one of these two options, letting it hold everything or writing one for each individual item, is really going to work for me in the long term. Okay? So generics comes along and says, well, we can solve that problem. Write an array list with when you declare it, you provide it a variable type. Generics use type variables. And I'm going to use one of two letters. And I'll explain why. This is what you'll see when you go look at the documentation. You'll see people, when the type is a variable, they'll use T for type. Okay? When it's a collection class that you're building generics for, we use E for element. Okay? So I don't necessarily really care if you restrict yourself to using T for type or E for element, but when you look at the documentation and some class uses generics, you're going to see one of those two variable names. Okay? Now, so a little bit more about that in a second, but let me sidetrack to something that you've already seen where we've been using generics already. So the syntax that I provide if I'm using generics and I want to create an array list is I simply, in these angle brackets, provide the class that I want it to work for. Then Java will automatically make it so that the get method returns a tire type. Okay? If I just change my mind and I want this array list to hold pizzas, then I can change what's in those angle brackets, and Java will automatically adjust the get method so that it returns a pizza object. Okay? So the angle bracket notation for generics, like for templates, is trying to solve this problem down here. This array list is too general. Okay? I can throw everything together, and that's probably not what I want 99% of the cases. And this is too specific. Okay? So write one array list that's set up with this angle bracket notation correctly, so that I can just plunk down any old class name and Java will fix it for me so that the array list works for that particular type of class. Now, today we're going to see how to do that. Okay, what's going on behind the scenes? How do I use these funny type variables to make that happen? That's the main purpose of today's lecture. So we've been doing it already, and it probably didn't bother you too much because you saw the template notation from C++. But that's what we're doing there. Okay, Java's filling in, making the adjustment at all the internal stuff in that class to make that one array list work for pizza. Okay, so I only ever have to write one array list. It'll work for all the different types of stuff that I want to put in there. Okay? So rather than stick with array list, let's change gears and use another class. In fact, we're in the node class here. That's where I want to start. So eventually, very soon, it won't take very long to complete the node class, I want to generics enable a queue-linked implementation, okay, which is going to use the node class, and a queue array implementation for reasons that I'll explain. Why to do all of this? Well, there's a reason. Okay? Now, the queue-linked implementations, we're going to find some simple rules are all you have to follow to make sure that your queue-linked will now function with the angle bracket notation. So array list, that's done for us. Java has already generics enabled that thing. All we got to do is put the brackets in and specify a class. Okay? But now we want to do that ourselves. We want to write classes where we can then later on use the angle bracket notation and have that class work for a specific type of object. All right, so we're going to start with the node class. So let me delete this stuff. At least this much. Yeah, it's gone. Okay, so I've got some rules up here at the top that we're going to follow. And then I've got a node class which should remind you of stuff that you did in data structures. Our first queue is going to use a link structure where we put the objects in nodes. And they link to each other. It's a circular link as well. So there's only next links, but it goes all the way around back to the beginning. Okay? What does the rule say? Well, rule number one, when you see a class name, append T for type or E for element. Since nodes only contain one item, I'm going to use T for type. Okay, you don't really have to, I don't care what you do on the exam. You can use it. You don't have to think through which one makes sense. Use one of them, and I'll be happy. It will work. Okay, but if I'm using this to specify a type that's going to be stored in this node class, then I'm going to use T. If it's part of a collection class where I have a whole bunch of elements, then I'm going to use E. Okay, so eventually we'll have to use this E as well. But T stands for type and E stands for element. So when you see a class name, append T or E to it. So there's a class name. So object is a type. It actually also is a class name, but it's got its own special rule. Rule number two is what to do with object. So anywhere else, let's complete rule one before we move on to rule two. With the exception of type object, we're going to go through here and do this angle bracket T thing everywhere that we see node. Okay, in fact, the rule says, if I just follow the rule explicitly, this is what it says to do. Okay, I think I got all of them. Okay, that's rule one. Rule two says, when you see object, replace it with T or E. So we're not using the top level class anymore, because as it is, node can store anything. I made it so it stores object, which means it can store pizzas, tires, whatever else. Okay? The problem being, when I try to get the item out, I want it to be the actual type and not this object type. Okay? So we got to fix that second step up. So wherever you see object, replace it with T or E. So I want to store not object type, but whatever it ends up being plugged in for that variable. Okay? That's how we link together. When we create our array list and put angle bracket tire in there, that's an actual class. That's going to be plugged in for everywhere that we have this type variable. Okay, so it's a special kind of variable that only means something to the interpreter, not to our general purpose programming stuff. Okay? So we specify what that variable is supposed to be when we specify a particular class. So eventually it'll become pizza or tire. But right now, it's just T. It's just a variable name. So I go through here, and everywhere I see object, I'm going to replace it with the T. Oh, come on. I'm going to try to complete the second step in a finite amount of time. Okay? Save that. Step 3, not the constructor definition class name. So specifically not there and not there. Okay? And then finally, the only thing that's actually going to turn out to be kind of difficult is step 4, but we don't have any arrays in this problem. The node class doesn't have an array. In fact, QLink doesn't have an array either. So we're going to avoid the issues associated with 4, and that's why I want to do QArray as well, so we can see how that's going to be different. Okay? Let's go through and apply those first 3 rules to QLinked. Okay, so I've even was very nice about including the same steps in here. There's a class name. Here's a class name. Not the constructor. Skip it. Object. It's going to be replaced with a T. Here's a class name. Object gets replaced with T. Class name, and then here is probably the only confusing part. Now we already said on the other file that not the constructor definition. The constructor definition is here. We're defining node's constructor. I'm calling the constructor here, so it's not subject to that one exception to the rule. So it's a class name. I put a T there as well. Object. Class name, and well, I probably missed one, but that's okay. You can see what happens. In fact, let me intentionally miss one. Okay. So, in fact, let me get it working first, and then we'll experiment with what you can expect when you have a mistake. So let me see if this thing now compiles. Okay, it did. So now I want to go to our PQAL driver, or do I have, we can put a driver in here. How would we use this thing? Okay, we have now finished generics enabling it. But it's not going to make a lot of sense what we've done here until we try to tie it together with using a QLink to do something. So, static void main. So now I can decide what I want to put in here. How about a rational number? Sounds good to me. Okay? So what I have done, or what what Java is going to do for me, is it's going to say, aha, so now they're using a QLink for a specific purpose. Someone has decided that they would like to store rational, we're not going to ration these numbers, rational number. We want to store rational numbers in a queue. Okay? So because we've generics enabling it, this should work. So what's going to happen is everywhere that there was, for the QLink class, we can look and the Java interpreter is going to say, aha, let's line these up. They want me to replace everywhere where there was a type variable with an actual class name rational number. So it does that comparison. They're declaring this thing with rational number. Oh, look at the very top level statement for the class QLinked. We've got a parameter there. We've got a variable type. They're asking me to replace that variable type with rational number. So the interpreter goes through there and does that for us. And so when we want to get a number out of there, a rational number out of there, it's going to come back as type rational number, which I guess we should go down to DQ. Okay, when we DQ something, it's going to come back as type rational number, which is exactly what we want it to do. And that's the way we've been using ArrayList to this point, because we were always doing this stuff with ArrayList. We were filling in what's was already done for us as far as making ArrayList generics enabled. We were just filling in that variable with a particular class, and then when we call the method, the get method, we get back a type of that class. Okay. Okay. So a lot of confusion with respect to generics, especially when it comes time for your first exam, where I'm probably going to ask you something about generics, is when do you use the variable type? So you followed all these methods, these rules here, but still you're confused about when do I put in an actual class and when do I put in a type variable like T or E. Here's the thinking that you should probably go through to make that determination. If you don't know what's going to be stored in that thing yet, you're writing it as someone who could potentially use it, but at that point you don't know what someone might want to store in there. You want to write it so it stores anything. Okay? So when I write the QLink class, I want to make it so as the writer of that class, I want to make it so that it's as generally useful as possible. Okay? I don't want to make it so it only works for rational numbers. I want to make it work for any class. So when I'm writing QLinked, I'm thinking to myself, I don't want to specify what's going to be stored in here yet. I want to let someone else who wants to use this thing do that step. So when you haven't decided what's going to be stored in there, or you shouldn't have yet decided what's going to be stored in there yet, use the variable type. Okay? So that's when we go through the step of converting the objects to T's and all that kind of stuff. We're trying to still make it generally useful. We haven't yet decided what's going to be stored in there. Later on, when you start working more on your program, you decide that you want to come back and now make use of that thing that you wrote. You know what you want to store in there. Okay, I want to put pizzas in there. I want to put tires in there, whatever the case may be. That's when you use the angle brackets with an actual class specified. Okay? So it really shouldn't, at least after thinking about it some, you get the hang of it. Do I know what I want in there now? If so, then I need to plug in a particular class name. Okay? Or, well, I'm writing this thing, so I don't know what's going to be stored in here yet. I'm trying to make it generally useful, so I should leave it as a type variable. Okay? So you got to think about someone who's designing that collection class versus someone who might be using it. Okay? But I'm used to seeing those concepts get all mismatched on an exam. Okay? But, that's the thinking. All right, what happens if I make a mistake? What happens if I forget to say, put that thing in there? Now, just randomly selecting one thing to go wrong may or may not actually show up as an error, and that's why we got to spend some time talking about this. I think that one will, but we'll see for sure here in a second. Okay. Okay, so that's another error that's not related to what I just did. I forgot rational number. Well, you probably don't know this. So let me show. I didn't put those things in a package. So there's no package statement at the top. I didn't put them in a subdirectory. Rational number is defined in CSC 2310. So if I want to use it in here, I've got to import that thing. Okay? And that's better. So this is the kind of error I expected to see. These can get really cryptic if you have a mistake. Okay? So what it's saying is object cannot be converted to T. And that's basically referring to line 50. Okay? If I don't provide the brackets, what Java is going to do for me is plug in object. So really, everything has angle brackets. Everything's been generics enabled. If you don't specify, then it's assumed that any type variables that you use, you're going to plug in an object for it. Okay? So I got this error because I left off the type variable. It needs to associate node with T. And those can become increasingly cryptic. That one's not so bad. In fact, it even gave me a line number pretty close to where the error was. That may or may not be the case for you. Okay? So, let's put that in there, and then hopefully that will take care of that. That did. Okay? Now, sometimes when you make a mistake, you will get, was that a warning or an error? Let's see. That's an error. Okay? Sometimes, if your mistakes are more subtle and not, as obvious as this one was, for the interpreter anyway, you will get warnings. Okay? And of course, your temptation is to ignore them because your program, the GUI came up and some stuff happened. Okay? It's never a good idea to ignore the warnings in generics. Eventually, the whole point of generics, well, actually, there's two important things. The first one we already covered. It allows me to write one class, one collection class, and have it work for an entire variety of stuff to be stored in it, like what we just did for QLink. Okay? The second thing is, which I just forgot what it was. Nope, completely gone. So hopefully I'll think of it in the next couple of minutes. Okay, so there are two important things that come from generics. We've talked about one fairly extensively. I'll think of the other in a second. Okay, so if you get some bizarre warnings, in fact, what you would like to be able to do, what Java will do by default, if you have warnings associated with your generics, it'll simply tell you, it'll give you a cryptic message. You've got some problems with your generics. I don't remember exactly what the wording is. We want to set this thing up so we force Java, whenever we're dealing with generics, to give me all the warnings. Of course, it's going to tell you about the errors. Okay? But we also want to see all the warnings. So we can set that up. In the next couple of lectures, we're going to start next week. We're going to start talking more about what's going on with the batch file and the XML file. Okay? But one of the things I can do in the XML file is I can tell Java to show me all the warnings associated with generics. Okay? Because I really should get rid of them. Oh, I do remember. The other thing that generics do for us is it can be dangerous if I leave that stuff. So the other way of making my collection class work for anything is leave it all as object, like in our very first example. However, if I get back everything as that top level class type, I may need to figure out what it is. I really put a pizza in there. I really put a tire in there. Okay? If it comes back as object, I have to guess. Now I don't remember what it was. And if I guess wrong, I'm going to get an exception. So it allows us to write one class that works for all different types of objects, and it will eliminate, and we'll talk about this exception increasingly as we work our way through the semester, it tries to eliminate a runtime error exception. You guys remember the three types of errors? Let's go back to our text file. What are the three types of errors?
Syntax.
3 is logic. There's a 2. Runtime. Okay? Which one is the worst one to deal with? Okay. So if at all possible, we want to convert problems up. We want to take the higher number issues and make them be lower number issues. So it really allows us to take a very common type of run type exception, guessing wrong about the class type, and makes it be a compiler reported thing that then looks more like a syntax error. Okay? So it's two really important things. Whenever you can reduce the complexity of an error, you're going to save yourself a lot of time. Okay? Now later on, we'll actually be able to do something with going from 3 to 2, but we're not ready for that. So it takes us from a particular common type of runtime exception and turns it into something that looks like a syntax error. Okay. Oh yeah, it was over here. So we're going to look at how do I set up my XML file to force Java to show me explicitly all the warnings that occur due to generics. Oh, brother.
Just drag it in.
Yeah, thanks. Yeah. Okay. So, a lot of cryptic stuff. Not ready to talk about most of this stuff yet. Okay. So, I'm running so I'm running CS3. So the current class that's got a driver that I'm running is the leftover stuff from last time. As you recall, I guess it's gone now. But we were talking about priority queue and it came out in sorted order. So that we had done in this PQ driver thing. Okay? Well, one of the things that I can do is add a line in here. One of the things that the ANT program, which is the thing that's using this XML file, one of the things it's designed for is letting me pass messages to the Java interpreter. Okay? And one of the things that we really want to do is we want to tell it to, as I was just saying, make sure to show me explicitly all of my warnings associated with generics. Okay? Now the syntax for that, I think I'm probably going to have to look. Maybe it's here. Maybe I can cheat and look in here. Yay! I can cheat and look in here. There's no way I would have remembered that. Okay? And I don't necessarily expect you to remember that either. So that's why, I'm going to provide you in lab and stuff. This may very well be given to you so you don't have to remember all this funny syntax. In particular, this phrase here, this unchecked thing, what that's referring to is the type of exception that we're trying to get rid of is a class cast exception. That's when I have this object type, the top level class, I try to guess what it actually is and I guess wrong. Okay? So that means I wasn't correctly checking the type using generics. So that's where this funny phrase comes in, this unchecked thing. Okay? So what this compiler argument is trying to do is it's telling Java, don't just tell me there are warnings with generics, show me each and every one. So let me see if now it will still work because we fixed our problem. Didn't I just copy that from this other file? Oh, did I put it in the... I did. This is in the wrong spot. Come on. Select. It's actually supposed to be here in build. Okay? Because it's not associated with running. We're still trying to compile the thing. So that compiler argument should be set when I'm building and not necessarily when I'm running. Okay. So now it compiles. All right. So I think when I put this up on the web, this example that we're working, I'll leave that in there so you have that. Okay? So, in the cases, so just watch out. Off the top of my head, I'm probably not going to be able to come up with some. Q-linked is pretty simple. The steps to generics enable it were not that involved. So it's going to be difficult for me to come up with a situation where I get some generics warnings that aren't errors. It's always going to report the errors to me. It won't always. It'll. If I don't have that compiler argument in there, it won't show me the warnings. It'll just say there were warnings. Okay. So let me warn you about the warnings. If you, in fact, don't fix them all and you leave some uncorrected, when I run your program, when I'm actually grading your program, and one of the things I'm certainly going to be grading for on your programming assignments is if you use generics correctly. It's going to be worth some points. If I'm grading your program, I'm going to have that compiler argument in there. And I'm going to see all your warnings. And if they're still there, you're going to lose points. So the best thing to do is to make sure that you always have that in there. Okay, whenever you build a project, just make sure that you've got this tag in there so it will always display all your warnings and you will know to try to get rid of them. Now, I can also tell you that frequently students have been looking for trying to get rid of all their warnings and their errors and just can't find them all. Okay? You're not always going to be given the exact line number where the problem is. In my simple error, it was pretty close. It made it easy. But sometimes where the problem is detected and where actually the error in your code actually is are in two different places. Okay? So I've fixed 1 million of these. I don't mind if you have gotten to that point, you've started ahead of time and didn't procrastinate, and you can't get rid of all your warnings, bring it to my office. I'm probably just going to look down there and say, there, you missed that one, you missed that one, you missed that one. Okay? So you just kind of get used to looking through there and knowing exactly what it's supposed to look like. But it takes some practice, and I don't necessarily expect you guys to be there yet. Okay? You follow the first 2 steps, but you miss some. You scroll down there, it's certainly easy to miss some of them. And depending upon which ones you miss, it's going to give you an error. It's going to be obvious, or it may not be so obvious. Okay? But you have to get rid of all of them. Now, having just said that you have to get rid of all your warnings, there in fact is one that you can't get rid of. Okay? So always, except for the exceptions, always do everything. Okay? So now I need to turn to show you an example of where that occurs, I need to switch gears. I need to look at the 4th rule. Generic arrays, that's where that's going to occur. We're going to have a statement in there that, first of all, shouldn't even work. Okay? So we're going to go through and we're going to apply the rules like we did for node and Q-linked. And it's not going to work. Okay? Then we're going to say, well, what can we do to try to get this to work? And everything we try is going to be incorrect. Okay? Because the answer to how to fix this particular case should not even be a legal Java statement. I don't know whether we'll be able to determine that yet, but later on we can look back and see that this makes no sense. Okay? In fact, the first time I tried to I learned about generics, I was trying to generics enable my own array list, I could not figure out how to get rid of this warning. So I actually had to download the array list source code and copy how they did it. And then it worked. But I still had a warning. Okay? Everything worked fine from that point on, never had any trouble with that array list, but there's one warning I couldn't get rid of. Okay? All right, so that's going to be Q array. I have no idea where I put it. Okay. So don't worry about that stuff at the top yet. We'll come back to that in a later class. So Q array. So let's apply our 2 rules. So at this point, I'm trying to write Q array so it holds anything. So I've got the correct mindset that I need to be putting T for type or E for element in here. I need my variable type to be a variable. Okay, I don't want it to nail it down to a specific class. I want to be able to fill in the class name later. Okay? All right. So there's a class name. In fact, I'm just going to copy paste. Not here. Remember, the class definition doesn't get one. Is that all, really? Surely I missed some. Okay, I guess because we don't have any nodes or anything like that, that's it. Okay, that's the first rule, pretty easy. Now I've got a bunch of these. I've got object all over the place in here. So now I want to associate it with this variable. That's how Java knows where, when you specify something in the angle brackets, it knows that it's got to go through and find all the t's that you've placed and plug in that class name. Okay? So that's eventually going to be a specific type of array. But right now, I need to go through and convert all these. And I'm going to be stubborn and not replace all, just to make you suffer. Most of you aren't even listening to me. Okay, I think I got them all, but I expect to have some problems because generic array, what I am trying to do here, this declaration here, and more specifically creating the array here, that's called a generic array. Okay, and you simply can't create them this way. So I expect to get some issues with my compilation here. Okay, generic array creation, complained about. Well, I missed one. I've got an object there. QArray 107. Okay. So, okay, now I got three of the exact same thing. Everywhere I tried to create a new array, it's going to complain about generic array creation. Okay, so now those are errors. They would have shown up even if I didn't have that compiler tag in there. Okay, for unchecked. So I got to figure out how to do this. The way that you have to do this is I've got to make it be type object, and then cast what it is to be an array of type T, whatever the user plugs in for this thing. Okay? That's bizarre, and although it might not look like something that should be impossible yet because we don't know about inheritance yet, but this should in fact be an invalid statement. So without looking at the source code for ArrayList, I doubt I would have ever stumbled across this on my own about how to do this. Okay? So I need to go in and plug that in, those three spots. How much did I actually copy? Not enough, apparently. Okay, so here we go. I've got a warning, uncheck cast. I've got another warning. So all three of them. They basically gave me the exact same warning. Now, just to experiment, I wonder what my output would be if I took this out. Okay, so there we go. It says, with this bizarre thing, recompile with this parameter set for the interpreter to show you the warnings. So if you don't have that thing in there, that's easy to miss. Okay, you can overlook that pretty easily, and there could have been 100 of them. You don't know how many warnings there were. Okay, so I'm not going to miss it. I'll notice it if it's still there. So I expect that for purposes of looking at your warnings and determining which ones I'm willing to let go and which ones I'm not, The only one that these are the three that you should be left with. Okay? You can't get rid of these. Because the only way to make this array thing work with the type definition, the angle brackets, trying to generics enable an array-based collection class, which is very common, i.e. array list, you have to do this statement that actually makes no sense. So later on we do more with inheritance. I'll come back to the statement. I'll try to explain why it's nonsense. Okay, but we don't necessarily need to worry about that right now. But that's the exception to the rule. So let's see, those rules were in generics array is a special case. We have a warning that we can't get rid of. Okay? We have to make it so that that array can accept different types. That we can plug in for that value of t and the array be created based on whatever the user specifies in their angle brackets. Now, so how would we use this one? If we suppose we wanted to use QArray in a program. Where did I put that main method? It's in QLinked. Okay. No difference. Because remember, the whole point of encapsulation is one of the main benefits is we can hide the implementation from the user. So in fact, it might have been nice if instead of calling it QLinked or QArray that I just called it Q. Okay? Have this be the type that I use. That way they don't know what it is. In reality, if I were doing this, as part of a software engineering project or, working for a company or something like that, I would not have used my in-class convention of, here's what it is, that's the thing on the left, the thing on the right is, here's how I built it. Okay? I need that if I'm going to show you the different ways to implement stuff and talk about the cost, the trade-offs with the different types of implementations. I need to be reminded how that particular one was built. But in reality, the idea is we're going to hide that implementation from the user. They don't really need to know whether it's a linked or an array. Okay? They just need to know it's a queue, and they know the methods then that they can call. On queue and dequeue specifically. And for a stack, it's push and pop. Okay? So they better work exactly the same way. The difference being that when I compile this thing, sadly, I'm going to get some warnings associated with the generics array. Okay? So that's another way that we're going to accidentally, even if I call this thing just Q and not QArray, it's going to give away via those warnings that there's array being used inside there. Okay? So on your programming assignment, if we're doing some kind of generic stuff and there's an array involved, please remember that you are allowed to have some warnings left over, although I recommend you still have them displayed out like this, because if you look through there and see, aha, it's all generic array stuff, then I'm good. Okay, I know that I can't get rid of those, but all the other 50 errors are stuff that I can probably deal with. Okay? So if you do end up with 50 or 100 of those and you just can't find the spots where you've made a mistake, please bring it by. I'll look at it. It probably won't take me long to find it. Okay? There's always a problem somewhere. And that will be exposed if you have it print out all your warnings. So occasionally the error that you make doesn't show up as an error. You've left something out, your generics are not quite correct, but it's not egregious enough to show up as an error, so it shows up as a warning. So you have to actually see that stuff going on behind the scenes, and that's how we do that. Okay. So, hopefully a couple of things that you can think about with respect to summarizing today's lecture was the couple important things to take away. We're saving ourselves a lot of programming effort to use generics, just like templates in C++. However, I'm going to try to hit on the tricky things when I ask this on an exam. And one of the things, of course, I'm going to ask you to do is generics enable a class and then use it somewhere else. So, as I mentioned when I talked about that, you've got to be able to look at the problem and realize whether you're going to be placing in an actual class name or whether somewhere you're going to be using a type variable. Okay? So just think, do I know what's, at this point of what the thing that I'm writing, do I know what's supposed to be going in here yet or not? If you do know what's supposed to be going in there, then you probably need to plug in an actual class name. Okay? If you don't, then you're probably defining the thing and you need to use type variables. Okay? I won't say that that reasoning will work in 100% of the cases, but in here, anything that I'm going to give you, it will work. Okay? Just need to think about it and decide whether you know what's supposed to be going in there or not. You know, that seems to me a pretty simple distinction to make. I see all kinds of crazy stuff on exams. Okay? Wrong stuff everywhere. Even stuff like this, using rational number correctly in one spot, but then over here putting a T or an E. Okay? So I've seen it all. I would be surprised if you guys come up with any new wrong answers, but hopefully you all come up with the unique correct answer. Questions? All right, have a good weekend. Thanks.